Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a really interesting question from entrance examination. Square root of 30 all over square root of 10 minus square root of 5, and we raise all this expression to the power 10. Extremely great and tricky question, so if you want to test your school knowledge or algebra skills, you can easily solve it on your own and write your solution in the comments below. It will be really interesting to read about it and to exchange information and of course to check our answers. It will be really interesting. Okay, so right now let's start. First of all, I'm going to start on the left side. Let's do it on the left side. Okay, square root of 30. Let's write it as square root of 5 times square root of 6. Okay, so square root of 5 times square root of 6. In our denominator, instead of this square root of 10, let's write square root of 2 times square root of 5. Okay, square root of 2 times square root of 5. And of course, minus square root of 5 minus square root of 5. Raised to the power 10. Right now, if we look closely from a different perspective, in our denominator we can factor this square root of 5. So let's do it right now. So we have square root of 5 times square root of 6 in our numerator, and in our denominator we have square root of 5, we factor it, and in parentheses we have square root of 2 minus 1. So square root of 2 minus 1 raised to the power 10. So right now, we can easily cancel this square root of 5. When we factor it, if we factor it, we can easily cancel it. So as a result, we have only square root of 6 in our numerator, so we have square root of 6 in our numerator. In our denominator, square root of 2 minus 1. So square root of 2 minus 1 raised to the power 10. Right now we have a fraction, and if we raise a fraction to the power, for example, in our case 10, so it means that we have to raise our numerator to the power 10 and our denominator to the power 10. So let's do it right now. So we have square root of 6 we raise to the power 10, and our denominator square root of 2 minus 1 raised to the power 10. Right now, square root of 6 to the power 10, we can simplify. We can write it as 6 to the power 5 because square root is the power 1/2. So that's why we divide this 10 by 2. So we have 6 to the power 5. And in our denominator, square root of 2 minus 1 to the power 10. Right now, one really interesting moment, because 6 to the power 5, this is a table case, so that's why I write it, but this is up to you. You can leave it like that, 6 to the power 5, and you can multiply it on your own, for example, on the right side or on the left side. I know it as a table case. This is equal to 7,776. We can leave it like that. And we divide it by square root of 2 minus 1 to the power 10. Okay, so this is our first step. Right now we can easily say, okay, our numerator is okay, is great, we can't simplify this more, we have a constant. What about our denominator? So of course we don't have a fraction in terms of our denominator because we have only square root of 2 minus 1, but we still have to raise this square root of 2 minus 1 to the power 10. So that's why our next step is to evaluate, is to simplify this expression in our denominator. So let's do it. So square root of 2 minus 1 to the power 10, this is our next step. And in the end, we will plug in it instead of this denominator. Okay, so let's do it. How can we evaluate it? How can we simplify it? My quick recommendation. So my method. So let square root of 2 minus 1 equal to, for example, x. So this expression right here in our parentheses equal to x. So we need to solve for x to the power 10 because this is equal to x. So we need to solve it for x to the power 10. Right now, let's rewrite this expression, but first of all, I want to write x on the left side and this constant on the right side. So we have x equal to square root of 2 minus 1. Square root of 2 minus 1. All right. The next step, let's add a 1 to both sides. So we have x plus 1 equal to square root of 2. X plus 1 equal to square root of 2. Right now, let's raise both sides to the power. So right here we added 1. Right here we raised to the power 2. So that's why we have x plus 1 to the power 2 equal to square root of 2 to the power 2. Okay, on the left side, this is our school identity. So x squared plus 2x and plus 1. On the right side, we can easily cancel this square root sign with this 2. So as a result, we have only 2. All right. Right now, let's continue right here because I don't have enough space. So let's continue right here. But let's subtract 2 from both sides. So we have x squared plus 2x plus 1 and minus 2 equal to 0. So we just subtract 2 from both sides. And when we subtract 1 minus 2, we have minus 1. So as a result, our final expression, x squared plus 2x minus 1 equal to 0. And a lot of students might be thinking that we have to solve this quadratic equation, discriminant, and other things. But from here, we really need to express our x squared. So x squared equal to 1 minus 2x. So x squared equal to 1 minus 2x. And this is the key expression for us, because as I said before, we need to evaluate it for x to the power 10. So that's why this x squared is extremely great expression, because first of all, it helps us to reduce a power. So in terms of x squared, we can express our first power, yeah? So x squared, we can exchange it with the first power, because this is our first power, this is our second power. So first of all, it helps us to reduce a power. And secondly, we have to solve for x to the power 10. Right now we know x squared. So our next step is to raise this expression to the power 2. Then we will have x to the power 4, then once more we will have x to the power 8, so we can get closer and closer to this x to the power 10. So that's why our next step is to raise this expression to the power 2. So we have x squared equal to 1 minus 2x. So this is our expression from the first step. Right now we raise this to the power 2 and this to the power 2. So let's simplify this. What do we have? X squared to the power 2 equal to x to the power 4 equal to, and this is our identity, this is our school identity, 1 minus 2 times 2x and times 1 and plus 2x squared. Okay, and let's simplify it. So we have x to the power 4 equal to 1 minus 4x and plus 4x square. Right now, really interesting moment. We can leave it like that without any changes, but in the same way, x squared equal to 1 minus 2x. So let's write the next line, but x squared equal to 1 minus 2x. Okay, and right now, instead of this x squared, let's plug in 1 minus 2x. It helps us to reduce a power, so then we will have two expressions, not three, because we have 1, 2, 3. Then we will add something with x, with variables, with a constant, so it simplifies our expression a lot. So 1 minus 4x plus 4, and instead of x squared, we have 1 minus 2x. So 1 minus 2x. So let's simplify this. So we have x to the power 4 equal to 1 minus 4x plus 4 and minus 8x. Okay, from here we have x to the power 4 equal to 1 plus 4 equal to 5 minus 4x minus 8x minus 12x. So this is our x to the power 4, and as I said before, we're getting closer and closer to this x to the power 10. We really need to solve it for that. We know x squared. Right now we know about x to the power 4. So the next step is to solve for x to the power 8, because it's easier for us to raise both sides to the power 2. We will have x to the power 4 raised to the power 2 equal to 5 minus 12x raised to the power 2, and then we will have, from here we have x to the power 8, and then we getting closer and closer to this x to the power 10. So the next step is to evaluate, is to simplify this expression, x to the power 4 to the power 2 equal to this one. So first of all, on the left side we have expression that we really need. We have x to the power 8, x to the power 8, and on the right side we have basic identity. So 5 squared minus 2 times 5 times 12x and plus 12x squared. Okay, right now let's simplify this. So we have x to the power 8 right here. So right here like that. Let's put this paper like that on top of it, because I want you to see all of the solutions. So equal to 5 squared 25 minus 2 times 5 times 12 equal to 120x, and plus 144x squared. And according to the same logic, because we have it right here, when we have a square, so we go to this expression, x squared equal to 1 minus 2x. Okay, so but x squared equal to 1 minus minus 2x. So right now, instead of this x squared right here, let's plug in 1 minus 2x. So let's do it. We have x to the power 8 equal to 25 minus 120x, so without any changes, plus 144 times x squared equal to 1 minus 2x. Okay, so let's simplify this expression. We have x to the power 8 equal to 25 minus 120x plus 144 from here and minus 288x. So right now let's group the common things. We have 25 constant, we can add to this constant, and we have this with x, we can add with this x. As a result, our x to the power 8, let's do it, let's write it. As a result, our x to the power 8 equal to 25 plus 144, we have 169, minus 408x. So this is our x to the power 8. As I said before, right now we know a lot of expressions, so these are x to the power 8. In the previous step we had x to the power 4, but the main thing, how can we solve it for x to the power 10? How can we evaluate it? The best way to do it is to multiply x squared times x to the power 8. We know everything about x squared from here, and we know x to the power 8, so that's why right now we will multiply parenthesis by parenthesis. So let's do it. This is our first step. So we have x squared times x to the power 8 equal to x squared equal to 1 minus 2x. So 1 minus 2x. We multiply it by x to the power 8, this one. 169 minus 408x. Okay, right now let's multiply parenthesis by parenthesis. But first of all, on the left side, we already have this x to the power 10. So this is our x to the power 10, the expression that we really need, equal to, right now, parenthesis by parenthesis, 169 minus 408x minus 338x and plus 816x squared. Okay, from here we have x to the power 10. Right now let's subtract this expression in the middle, so let's simplify this step by step. 169 minus 746x and plus 816x squared. And using the same logic, we can write but x squared, it helps us to reduce a power, but x squared equal to 1 minus 2x. So that's why instead of this x squared, we plug in 1 minus 2x. So let's do it. So we have x to the power 10 equal to 169 minus 746x plus 816, and instead of x squared, we plug in this one, 1 minus 2x. Okay, in the next line, let's evaluate it. Let's simplify x to the power 10 equal to 169 minus 746x plus 816 and minus 1632x. And right now, what do we have as the common things? We have two constants, and we have two expressions with the x. So let's do it. X to the power 10, let's add it. So we have 169 plus 816, we have 985. Minus, right here when we subtract it, we have 2378 times x. Okay, these are x to the power 10, but we don't need to raise it anymore because we have it. And right now let's go back to the beginning, let's go back to that substitution. So we had it on the first paper, x equal to square root of 2 minus 1. This is extremely important expression for us. Let's remember it, x equal to square root of 2 minus 1. And right now let's go to that line. So let's write it, but x equal to square root of 2 minus square root of 2 minus 1. Okay, square root of 2 minus 1. And instead of x, we plug in it. So we have, instead of x, we plug in square root of 2 minus 1. So square root of 2 minus 1 to the power 10, exactly expression that we need to solve for, equal to 985 minus 2378 times square root of 2 minus 1 instead of this x, square root of 2 minus square root of 2 minus 1. Okay, from here, what do we have? Square root of 2 minus 1 to the power 10 on the left side without any changes, equal to 985 minus 2378 square root of 2 and plus 2378. So in the end, let's add these two constants. So we have square root of 2 minus 1 to the power 10 equal to, as a result, we have 3363 minus 2378 square root of 2. So this is our expression that we need to find, but right now I'm going to write expression from the beginning and then we will plug in exactly that line. So in the beginning we had, so I'm going to write it as an answer to this question. So we have square root of 30, we divided by square root of 10 minus square root of 5. We raise this to the power 10, and we had that line that this is equal to 7,700 in the very beginning of our solution, 7,776 all over square root of 2 minus 1 to the power 10. This is our second line in the beginning, so you can scroll the video and you can easily see it. And we said that we have to simplify this, we have to evaluate it, and right now we have a result. This is our expression. We're going to plug in it right here in this spot in our denominator. So our final answer is 7,776 all over 3,363 minus 2,378 square root of 2. This is our final answer to this question. And of course there are a few really interesting hints. Maybe you can multiply numerator and denominator by the conjugate expression. Of course, if you're interested in this, you can do it. You can multiply it by this expression but with the positive sign, then you can consider a denominator as a difference of squares. So if you're interested in this, of course you can do it, but I can easily leave like that because we simplify it. Yeah, we don't have any tens power, and the main thing, we have square root of 2, but doesn't matter. This is how expression looks like, so we can't simplify this more, and of course this is our answer. I want to say thank you everyone for watching. If you still have any question, write a question in the comments below. Write your thoughts about this solution. How do you find this square root of 2 minus 1 to the power 10? It's also really interesting. Maybe binomial formulas, but a lot of students struggle with the binomial formulas. That's why I use this way to go step by step to x to the power 10. Maybe you have your way, maybe you have your response about this, maybe you have your assumption about this part. Yeah, and of course write your solution. Maybe you solve this question in a different way, maybe you evaluate something, maybe you simplify something. A lot of people all over the world, a lot of solutions. Maybe you study different method in your country. It's also really great to see from your perspective. This is my solution. I would like to say thank you everyone for watching, for being here, for supporting my channel, and this is extremely grateful from your side. It's extremely kind of you if you leave your response, your comments, your thoughts about this solution. On my YouTube channel we have more than like 600 questions, so I want to thank you for being here, for watching this video, because I continue my journey on YouTube, and I want to say thank you for your support, because without your support I cannot do the things, because this is a lot of work, a lot of content, a lot of questions, and I really enjoy it. If you enjoy it, I enjoy it as well. It's extremely great that we have that chemistry, that we have that solution, that problems, and I want to say thank you for being here, for watching my YouTube channel. It's extremely, I want to say thank you for watching, for supporting my channel, because a lot of comments, a lot of thoughts, and I see everything, and I want to say thank you for being here, for supporting my journey on YouTube, because my main goal is to make math clear and understandable for everyone, and I think my YouTube channel is helpful. If it did, like, I really want to say thank you for being here, for watching this. So wish you all the best in your life. Take care of yourself. Have a great day. See you in the next videos.